Welcome back everyone to another video in our Fundamentals of Structural Engineering course. In this video we are going to learn about deflection of trusses. Deflection of trusses is a very simple topic in this course and actually any problem on it on the exam you will find that most of it actually will be given, or let's say most of the steps, because it is a lengthy problem, so it doesn't make sense that you will get the full problem in the exam, because of course it will take way more than 2 or 3 minutes. That's why, as I will show you now, you will find that most of the answer will already be given, and you will be tested only to find out if you understand the process or not. The deflection of the truss is calculated using this formula, which is delta at any joint, which is the deflection, equals sigma of Fi multiplied by delta L. This is where Fi is the force inside the member caused by the unit load, and I will explain to you what does that mean, and delta L is the change in the length caused by the external effect, and it equals FL over AE. This is where F is the force caused by the external load, L is the length of the member, A is the cross section of the member, and E is the member elastic modulus. I will show you now how to use this formula to calculate the deflection at any point at any truss. The process of solving any problem goes through the following flowchart here. First, we calculate the length of each truss member. Second, we calculate the forces inside all of the truss members due to the X force, which is whatever external forces we have here. After that, we replace this X force with a unit force, which is 1. This is of course unitless, it's not kilonewton or ton or whatever, this is just a unit force. After that, we will calculate all the forces inside all truss members again due to the unit force, which will be the F small. After that, we will calculate this term here, which is F small multiplied by FL over AE for each member. And finally, we will calculate delta, which equals sigma F multiplied by FL over AE. This is why I'm telling you, of course, in the exam, you will never have time to solve through all of this. You will not have time to calculate all of the forces inside the members, then calculate the forces inside the members using the unit force, all of that. That's why most of this will be given to you, and you will only need to apply the remaining steps. And I'm going to show you now an example on this. Here we have this example. We have this truss here. There is a force of 40 kips applied at this point, and it is given that the cross section of all members is 4 inches square, and the elastic modulus of the steel is 29,000 KSI. We want to calculate the vertical displacement at point C, and this table is given already to us, which is all members, and F, which is the forces inside all members here, L, which is the length of all members, and finally F multiplied by L over A multiplied by E. So all of this is given to us. So now what we need to calculate actually only are those two terms, which are F small, and after that we'll calculate F small multiplied by FL over AE. So F small is the forces inside all of the members, but due to the unit load, not due to this force, which means that instead of this 40, we will have only one unit load applied here. So what will be the forces inside all of the members due to this one? Actually, you don't need to analyze the truss all over again to calculate this. Simply, you can refer to these values here. Due to the 40 kips here applied, you had 50 kips at the member AB, which is this member. So it makes sense that when you apply only 1 kilonewton here, or 1 kips, or whatever load you will apply here, the force at this member, it is going to be 50 over 40. We said that the F small will equal F over 40, because here we know that the initial force, it was 40 kips, and we replaced it by only one, let's say 1 kips also, so this means it will be proportionally also changed from 40 to 1. This means that the forces inside AB, it will change from 50. Again, you will divide it by 40, you will get 1.25. And the same applies here for BC, which is this member. Due to the 40 kips, BC had 49.2 tension force, which means that due to 1 kips, this value, it will be divided over 40, you will get 1.231. And the same for each one of these forces. And of course, if it is compression, also it will be compression, whatever tension will be tension, and whatever compression will be compression. So simply all what we have done here is that we divided all of these values over 40, because the F small is due to 1 kips, while the F capital was due to 40 kips. That's how we got this F small. And after that, simply we will just multiply this F small by this value given to us here, because this column here is F small multiplied by FL over AE. So we will multiply this 1.25 multiplied by 0.1034 equals 0.1292, and the same will be done for the remaining. And finally, in the end, we will just calculate the sigma of all of these values here, and we will get the final answer, which is 1.0464 inches. So the answer is the third option here, which is 1.046. So as I was just telling you, this is actually a very simple problem. If you have it in the exam, you just need to understand what you want to calculate, and it will not really take time from you, because if you have this question in the exam, all of these values, all of these forces will be given to you, and you will not be required to calculate the internal forces of the truss, because actually the time for each problem in the exam doesn't allow you to calculate all of this from scratch. So this is it for our video today. See you in our next video. Thank you.